You know how great it feels when you hear about a really innovative idea? Something that tackles a tough, persistent problem head on?
Yeah, absolutely. It's always exciting.
Well, today we're diving deep into just such a project. We're looking at this fascinating multi-agent swarm robotics system.
Designed for hospitals, right? Disinfection and monitoring.
Exactly. It's coming out of Dhofar University
Yeah.
with funding from MoHERI. Pretty groundbreaking stuff.
Seemed like it.
And our mission for this deep dive is really clear. Let's try to understand this system, how it works, and what its potential impact could be on hospital safety, efficiency.
Just affects everyone, really.
Right. And we've got some great insights to draw on, particularly from an interview with Dr. Qamar Ul Islam. He's an expert in robotics autonomous systems.
Good source.
Uh-huh.
So where do we start? What's the core problem they're tackling here?
Well, you framed it perfectly earlier. It's that huge challenge of hospital-acquired infections, HAIs.
Right. I mean, hospitals are for healing, but millions get infections there every year, and the cost, it's enormous.
Exactly. So the swarm tech is aiming right at that vulnerability, that sort of hidden threat in our healthcare systems.
A threat that really came into the spotlight during the pandemic, didn't it?
It really did. COVID-19 highlighted just how critical and sometimes maybe how fragile our sterilization protocols can be.
Yeah, traditional cleaning. I mean, it's vital, obviously, but doing it manually,
It has limits.
it does. Consistency can be tough, getting every nook and cranny every single time. And, importantly, it puts the cleaning staff at risk, especially with dangerous pathogens.
That makes sense. So the researchers basically asked, okay, can we get robots to do this?
Right. Can they disinfect automatically, intelligently?
And continuously, like 24/7.
Exactly. And their answer, the really innovative part, is this idea of swarm robotics.
Okay, swarm robotics. When I hear swarm, I think, I don't know, bees, ants.
That's actually a pretty good analogy.
Yeah.
Think about how ants work together, or maybe a flock of birds,
Yeah.
instead of one big, super complex robot trying to do everything.
You have a team.
A team. Exactly. Lots of smaller, maybe simpler robots. They coordinate.
How does that work in practice, though? What makes it a swarm?
Well, each robot follows some basic rules, but the key is communication and adaptation. They work together, cover large areas efficiently.
So they don't all just rush to the same spot.
No, they coordinate. They can navigate dynamically, avoid bumping into each other, or, furniture or people.
That's crucial in a busy hospital. So what are these individual robots actually equipped with? What can they do?
Each one is pretty versatile. First, the disinfection part. They carry modules.
Like little cleaning tools.
Sort of, either UV light emitters or maybe chemical sprayers to sterilize surfaces.
Okay, and what about the monitoring aspect?
They've got environmental sensors, so they're constantly checking things like temperature, humidity.
Things that might affect bacterial growth.
Precisely. They can even detect certain gases. It gives a real-time picture of the room's condition.
Wow, so disinfection and data collection.
Right. And critically, they have collision avoidance built in. Smart path planning algorithms, too.
So they figure out the best routes on their own.
Yeah, navigating safely is key. And then there's a central command system sort of overseeing everything, making sure the whole swarm works together effectively.
Like an air traffic controller for robots?
Something like that. Ensuring coordination.
It sounds incredibly complex to put together. How did they actually build this system? What were the main parts?
Yeah, it was definitely intricate. You could sort of break it down into maybe 4 key components.
Okay.
First, the hardware platform itself, the physical robots. They needed to be small, mobile, able to carry the sensors and the disinfection gear.
Right, the actual machines.
Second, sensor fusion. That's basically taking all the data from the different sensors.
Temp, humidity, gas readings.
Exactly. And combining it, interpreting it, to get one reliable picture of the environment. Kind of like how we use our eyes and ears together.
Makes sense. What's third?
Path planning algorithms. This is where AI really comes in.
The brains of the operation.
In a way, yes. It allows the robots to make decisions in real time. How to move, how to avoid obstacles, tables, beds, even people walking by. And finding the most efficient way to cover the area.
Okay. Hardware, sensors, path planning, and the fourth.
Swarm intelligence coordination. This is the layer that makes sure the team works well.
So stopping them from cleaning the same spot over and over.
Exactly that. Or making sure they don't miss areas entirely. It's about efficient, comprehensive coverage by the whole group.
That sounds like a huge engineering lift. I imagine they didn't just unleash these things into a real hospital ward straight away.
Oh, definitely not. No, there was a careful process. Lots of lab simulations first, testing the algorithms, the coordination.
Working out the kinks in a safe environment.
Right. Then they moved to controlled tests. They actually built mock-up hospital rooms.
Really? Like fake rooms?
Yeah, realistic ones. To see how the system performed in an environment that was closer to the real thing, but still controlled. It's a standard iterative process in robotics. Design, simulate, test, refine.
Makes sense. Okay, let's shift to the impact. If this works, if it gets deployed, what does it actually mean for hospitals, for the staff?
The potential is, well, pretty significant. Think about staffing challenges hospitals always seem to face.
Understaffing, burnout.
Yeah. This kind of automation could take over some of the routine and, frankly, hazardous tasks like disinfection.
Freeing up nurses and other staff.
Exactly. Freeing them up to focus on direct patient care. The things that really need that human touch, empathy, complex decision-making.
That's a really important angle. It's not about replacing people.
Not at all. It's about augmenting them, helping them do their core job better, maybe more safely.
And what about the environmental monitoring? You mentioned that earlier.
Yeah, that's another huge benefit. Real-time data on humidity, temperature. These can be early indicators, right? Maybe conditions are becoming favorable for bacteria to grow.
So the system could flag a potential problem before it even starts.
Precisely. It could send an alert. Hey, humidity's creeping up in room 302. Allows staff to intervene proactively.
Wow, so it moves from just reactive cleaning to actual preventative monitoring.
That's the goal, which overall should lead to increased efficiency and, most importantly, better safety.
Yeah, preventing infections. That saves lives. It reduces suffering. It saves money.
Absolutely. Consistent disinfection, early warnings.
Yeah.
It all points towards significantly cutting down those HAIs. Big potential impact.
Of course, building something this novel, there must have been challenges. Roadblocks, what were the big ones?
Oh, definitely. One of the biggest technical hurdles was navigation, specifically indoor navigation.
Ah, right. GPS doesn't work well inside buildings.
Exactly. We rely on it outdoors, but
Yeah.
inside. Walls, interference, it's unreliable. So they couldn't just use off-the-shelf GPS.
So what did they do? They had to build their own system.
Pretty much, yeah. They developed a custom indoor localization solution. It was quite clever, actually.
How did it work?
Used a combination of things. Vision slam.
Slam.
Simultaneous localization and mapping. Basically using cameras, visual data, for the robot to figure out where it is and map the area around it at the same time.
Okay.
And they combine that with RF beacons.
Radio frequency beacons, like little transmitters.
Yeah, placed strategically around the hospital.
Yeah.
The robots use signals from these beacons to get another fix on their position. Combining vision and RF gave them the accuracy they needed indoors.
That sounds really innovative. A custom fix for a tough problem. Any other hurdles, maybe? Non-technical ones?
Yes, actually. Adoption. Getting people comfortable with the technology.
Ah, the human element.
Right. You're introducing autonomous robots into a sensitive environment like a hospital. Understandably, some staff were initially maybe a bit skeptical.
Concerned about safety, reliability, jobs.
All of the above, potentially.
Yeah.
Questions about robots working independently, doing such a critical task. Building trust was absolutely essential.
How did they manage that?
Through demonstration, really.
Mm-hmm.
As the hospital staff saw the robots working, saw the results in the mock-ups and controlled tests, saw that they were reliable and effective.
They started to come around.
Exactly.
Sure.
That initial hesitation turned into support. Seeing is believing, you know?
Yeah.
It proved the value and safety, which was key for acceptance.
That's a great point. The tech is one thing, but getting people to trust and use it is just as vital. So, looking forward, what's next for this project? Where do they see it going?
They have some ambitious plans. One key thing is making the system modular.
Modular, meaning?
Meaning hospitals could scale it easily. Start with a few robots, add more if needed, or use it in specific wings. Flexibility for different hospital sizes and budgets.
That makes a lot of sense for real-world adoption, more adaptable.
Definitely. And another really exciting area is integrating machine learning more deeply.
Ah, making the swarm smarter over time.
Exactly. The idea is to enable the swarm to actually learn contamination patterns within the hospital.
How would that work?
By analyzing all the data, they collect sensor readings, where they've disinfected, maybe correlating with infection incidents. Over time, the system could identify high-risk zones or times.
And then prioritize those areas.
Precisely. Become even more targeted and efficient. Imagine the system learning, okay, Tuesdays after visiting hours seem to be a higher risk in the West Wing. Let's focus efforts there proactively.
Wow, constantly learning and adapting based on real data.
Yeah. It really paints a picture of this technology not just being a tool, but a core part of what they're calling, well, smart hospitals.
A blueprint for the future of hospital environments.
I think so, yeah. It shows how robotics and AI can create places that are safer, more efficient, and ultimately just better at healing.
This has been fascinating. So just to kind of wrap up the key points, we've looked at this multi-agent swarm robotic system from Dhofar University.
Tackling that huge issue of hospital-acquired infections.
Right, using these teams of coordinated robots. They disinfect, they sense the environment.
All managed by a central system using AI for navigation and coordination.
We talked about the engineering behind it, the hardware, the sensors, the clever path planning, that crucial swarm intelligence.
And the potential impact is huge, right? Helping with staffing, proactive safety through monitoring.
Potentially saving lives by reducing infection spread. We also touched on the challenges, like cracking that indoor navigation problem.
With their custom Vision Slam and RF beacon solution.
And the importance of building trust with hospital staff for adoption.
Yeah. And looking ahead, the vision is for scalable, modular systems.
That learn and adapt using machine learning, becoming a cornerstone of future smart hospitals.
It really does highlight the power AI and robotics have for tackling major public health issues.
It certainly does. And it makes you wonder, doesn't it? If we can do this in hospitals, where else could these kinds of smart, autonomous systems make a real difference in public health? It's definitely something to think about.